because the reason I know this is a circle is from my experience in math. All right, let's try this one out. Let's indicate the types of symmetry that this equation, x times y to the third equals 2. So let's try with respect to the x-axis. Again, what we do there is we sub negative y's. It's always the opposite letter. So everywhere there's a y, I'm going to put a negative y. Okay, so I have x times negative y to the third power equals 2. If I simplify that, since this is an odd number, negative times negative times negative gives me a negative. So to simplify that, this would give me a negative xy to the third equals 2. And I didn't make the x negative. What I did is negative y to the third becomes negative y, and negative times a positive gives me a negative result here. Now, is this our original equation, just like this up here? It is not. Since it is not, this is a no. This equation does not have symmetry with respect to the x-axis. Let's check if it has symmetry with respect to the y-axis. And remember, for the y-axis, our plan is to plug a negative x in for all of our x's and then simplify. So changing nothing else, all I'm doing is putting a negative x instead of a positive x. I get negative x quantity times y to the third equals 2. To simplify that, well, negative x, those parentheses really aren't doing anything. Just negative x times y is a negative. Is that our original equation? It is not, because this negative is here. It wasn't there in the original equation. We couldn't simplify it away like we did on our previous example because we don't have a squared. So once again, no, not symmetric with respect to the y-axis. Let's try the origin. Remember, our plan on the origin is to sub a negative x for the x's and negative y for the y's. So I get negative x times negative y to the third equals 2. Now when we simplify this, I bring out those negatives, one for the x and one for the y, which happens when I have those odd exponents. What's a negative times a negative equal to? Well, a positive. So I end up with a positive x y to the third equals 2. Is that the same as our original equation? Absolutely. So this one is actually a yes. It is symmetric with respect to the origin, and only with respect to the origin, not the x-axis or the y-axis. So the answer to this one is that it is only symmetric with respect to the origin. Okay, and that may come up quite a bit when you have those odd exponents multiplied by one another. All right, let's try this one. 4x plus 5y equals 9. Let's check for symmetry with respect to the x-axis. Hopefully we've got the hang of this. We put in a negative for our y, and then we simplify. Well, that gives me 5 times negative y is a negative 5y instead of a positive 5y. Is that the same as our original? It is not, because of this negative right here. So no symmetry with respect to the x-axis. Let's try the y-axis. So remember, for the y-axis, we put negative values for our x's, and we simplify. Negative x times 4 gives us a negative 4x. We still have plus 5y equals 9. Is that the same as our original function equation up here? It's not, because of this negative. So that is a no, not with respect to the y-axis either. Let's try the origin. So for the origin, I put a negative in for my x. I put a negative in for my y. And I simplify. That gives me a negative 4x, a negative 5y equals 9. Is that the same as our original function up here? It's not, because we have both a negative 4 and a negative 5, and they were both positive in the original. This is not with respect to the origin either, so this has none. It's not symmetric with respect to the x-axis, the y-axis, or the origin, and that will happen. Here is one more example. Again, remember you can pause this and even go back slides if you need to at any time. X plus y minus 1 squared equals 9. We want to check for symmetry. So for our x-axis, we put a negative in for our y, and we try to simplify it, but there's really nothing we can do to simplify this. This squared means the entire quantity, negative y minus 1 squared, which would be negative y minus 1. I'll write it up here. It's common to forget that that's what this means. And I would have to FOIL that whole thing out. So I can't just square the y and make it positive, square the 1 and make it positive. This is as simplified as this gets. So then we would say, well, is it the same as our original equation? And it's not. So this is not with respect to the x-axis. Let's try with respect to the y-axis. So we replace our x with a negative x, leave our y's alone, leave our 1 alone, leave our 9 alone. Try to simplify, but there's really nothing we can do to simplify the number negative x. So we're done. It does not look like our original equation, so there's also no y-axis symmetry for this equation. Let's try the origin. We put a negative in for our x, a negative in for our y, equals 9. Again, I can't simplify either of those things. There's nothing else I can do to this equation. It doesn't look like the original, therefore this is also a no. So it is not symmetric with respect to any of these, the x-axis, the y-axis, or the origin. Okay, here is yet another example. Y equals x to the third minus 2x. Let's test out our symmetry. So for the x-axis, I get negative y equals x to the third minus 2x. I can't really do anything to simplify this here. Okay, so I'm done. I could divide everything by a negative maybe on both sides to get the y back to look somewhat like it did before. But if I divide that side by negative 1, I have to divide the other side by negative 1, and I end up with a negative x to the third and a positive 2x, which still doesn't look like our original function here. So this is a no. Okay, let's try the y-axis. So we're going to put a negative in for all of our x's. Give me a negative x to the third minus 2 times negative x. Well, what happens there? I can bring the negative out in front when I have an odd exponent. Negative x times negative x is still just going to be negative x. Negative 2 times negative x is going to give me a positive 2x. Does that look like our original function? It does not. It has all of the wrong signs. So this is also a no for this symmetry. Let's try the origin. Sometimes it can be no for the top two and yes for the origin, so let's try that. So we put a negative in for our y's. We put a negative in for all of our x's. And we check to see if we can simplify and have it look like our original equation. Well, what do I get? I have a negative y. Again, that negative x to the third. I can negative x times negative x is just negative x. Negative 2 times negative x is a positive 2x. And can I go ahead and simplify this? I have a y, it's negative. To get rid of that negative 1, I can divide everything by a negative 1. When you divide one thing, you have to divide everything to keep the equation balanced. Gives me a positive y, a positive x to the third, and a negative 2x. That's as much simplification as we can do. Does that look like our original up here? It is the exact duplicate of it. So with our simplification, it did work out. So yes, this one is with respect to the origin, but not with respect to the x-axis or the y-axis. we had to have the combination of both the negative x and the negative y for that to work out. Okay, let's indicate the types of symmetry this one might have. This is our last example. Give us one more chance to work on this. Okay, let's try the y-axis. So again, we put negative in for our y and see if we might be able to simplify it to look like the original. Once again, that negative y, all I can really do is divide everything by -1 to clear that out. But then that changes my signs on the other side of the equation, so it doesn't look like the original anyway. So this is a big fat no. Let's try the y-axis. So we make our x negative. Well, there's nothing I can do to simplify this. That negative cannot be brought out in front of the radical. That breaks the rules of mathematics. It doesn't look like our original, so this is also a big no. Let's try the origin. Sometimes the origin works when the others do not. Okay, so looking at this, again, I could try to divide both sides by -1, but that negative would stay out in front of the radical and would do nothing for me. I would still have a negative x under the radical, which was not the case in the original equation, so it doesn't look like our original, so it is a no. This one also has none. Okay, so depending on the different equations, you'll get different situations. What you want to do is just test each of the possibilities. For the x-axis, you put -y for all of the y's and simplify. If you have a squared, that can be made positive, or a fourth that can be made positive. If it's a third power, that would remain negative. Okay, that type of thing. If it's the y-axis, we put -x in for all of our x's and simplify to see if we can get it to look like the original. And for the origin, we put negative for the x and negative for the y, and you simplify. Okay, so there are some examples of identifying symmetry in your equation.